All right, so we're starting a new unit. And like I said, we're going to kind of go back to some of the algebra stuff. But we're going to kind of keep it simple for this first section. We're going to talk just about some of the basic concepts of algebra and things that we use to kind of build upon. So everything that came from later in algebra, or even when you guys were in Algebra 2 last year, all of this is just building off of these foundational concepts that you probably talked about, even when you were back in like middle school. And if you were taking, your middle school math classes into your pre-algebra, algebra type stuff. So this is just kind of going over what we're going to cover in this section. And it looks like a lot. There's a lot of bullet points, but a lot of the stuff that we're going to talk about is kind of combining some of these objectives together. So there's going to be times where we talk about solving a problem, and that kind of includes involving order of operations, involving variables, looking at numbers that maybe could work. So we're going to take some of these ideas and kind of put them together. So really, I want us to go to this page, the back of your front one. And so we had this on our bell ringer today. We talked about what a variable is. Okay, and so remember, a variable is a letter that we use to represent something we don't know. So it could be a number that we're trying to find, an answer to an equation, something like that. And so most of the time, like I said, you're going to see letters. And it could be any letter. Usually we use X. Okay, but a lot of times they start to switch those. Like they might have a Y in there, an A, an M. It really doesn't matter what letter they choose to use. They're just picking one to represent what we don't know about a problem. Now, an algebraic expression is when you start to combine letters, like your variables, and numbers. And you're using operations like addition, subtraction, multiplication, and division. We also could have exponents. We also could have square roots. So any of these operations that you've seen before, when you start to combine them, are going to start to create expressions or equations, or maybe another way that you think about those, because then you're starting to solve for things. So an example could be if I had an expression that said 8 plus 6x minus 4x to the third, something like that. That would be an expression, because it has numbers, letters, it has exponents, it has plus and minus signs. Now, when I see something written like that, a lot of times I don't like it to be in that form, because I don't really feel like that's in the correct way to write it. We talked about something last year when we were dealing with polynomials with descending form. So you always want to start with the term that has the biggest exponent, and then you work your way down the line. So if you ever saw something like this and they were maybe wanting you to work with it, I would first suggest that you rewrite this so that you kind of put it in order. Now, I see an x to the third. That's my biggest exponent. So you're going to want to start with that term first. But really watch your sign here, because it is a -4. So I would put -4 x to the third first. And then what term would go next? 6x, and then 8. That's called descending form. Usually when we're working with polynomials, especially with things that have big exponents like that, and you're maybe trying to start combining like terms and things, you might want it to be in that form first, because it makes it easier to start to line up what can go together. Now, if we were evaluating an algebraic expression, so if we were evaluating something like that, there would be an equal sign in the equation somewhere, and then that would be kind of what we use when we start moving things around. So if you're adding or subtracting numbers over the equal sign, dividing or multiplying. And then that eventually will help us get to our answer. Then we also have the expression, where it's raised to a power. So like on this expression here, the little n, that's your exponent. And the b is called your base. Anytime we have that, those are considered exponential expressions, because you start to raise something to a power, you're multiplying that term by itself multiple times. And that causes things to grow really rapidly when you start to have exponents in there, because you're increasing the amount very quickly, which is why we call that exponential. Okay, so I kind of said this earlier today, but we're going to start off with just doing some order of operations type problems. Okay, so just a reminder, order of operations, you learn this as PEMDAS. Okay, and like I said, please excuse my dear Aunt Sally is a way that I remember those letters and what order they go in. But P stands for parentheses, but remember that could also mean any type of brackets. So not strictly parentheses. They could be like those harder like rectangle brackets. They could be like those squiggly ones that you've seen. Any type of bar symbols that you're going to see inside of a problem would be considered parentheses. Then E is your exponents, but that can also include roots. So this could be something raised to a power, but it could also be something that has a square root sign or a cube root sign in it. And then remember with multiplication and division and addition and subtraction, so I'm just going to kind of underline these two together. These go left to right. So after you take care of your parentheses, after you take care of your exponents or roots, you look at multiplication division together and you read the problem left to right, and whatever comes first you do first. So even if a division shows up before multiplication, you would handle the division first and then you would move on to multiplication. The same thing happens with the addition and subtraction. They're lumped together and whatever comes first when you read the problem is what you handle first. All right, so we're going to do a problem here and we're going to evaluate it. So we're going to solve it, but we're also going to just give a quick explanation of what we're doing. So what operation did we use to help us simplify? So we started with 8 plus 6 times x minus 3 squared, and we're trying to solve this when x is equal to 13. So the first thing that they did is they took this 13, and if you kind of follow the steps down here, they just plugged it in. So they put 13 in for the x, and now it's right there. Anytime that we plug in something, that's just called substitution because you're replacing the letter with an actual number. So for this step 1, I'm just going to say substitution. Okay, what did they do next on step 2 to go from that first statement down to the second one? What happened? Yeah, they took 13 minus 3 to get 10. Okay, so they did subtraction inside of the parentheses. So again, we're following order of operation. So I'm going to write parentheses. And I'll just put in parentheses after that a little subtraction sign because that's the actual operation that occurred there. Okay, then what do they do? They square 10. So that would be our exponent. Then what happened? Multiply. And then, good, addition. Most of the time when you guys are solving equations, you're not writing out the steps like that. When you were in geometry, you had to do stuff like that. Like that's very reminiscent maybe of algebraic proofs that you had to do in geometry, where you were solving a problem and you were specifying what did we do step after step after step. Most of the time, though, when we're solving equations, we're not writing out what did we do. We just know what to do because we have this process kind of ingrained in us because we've been using order of operations forever. So if you guys go on to this next one, I want us to just solve it. I'm not going to write out the steps that we did, but you kind of get the idea of what we should do. So the first thing that we need to do is plug in our variable. So what number are we putting in for x? 5. Good. So anytime I plug it in, I always put it in parentheses. So 2 and then 5 squared minus 3 plus 5. What are we going to do next? Add the 3 and 5. What do we get there? 8. And since they're adding and like there's nothing else to do there, I'm just going to drop the parentheses from the problem. Then what would you do? Exponent. 5 squared is? Good, 25. Now what? Yep, which is 50. And 50 minus 8 is 42. Good. When you're doing problems like that, I was very specific and like step by step by step. There would be times where maybe you could consolidate some of that work and not have everything written out. But if you're consistently getting order of operation problems wrong, then you need to slow down and you need to take it piece by piece. Because a lot of times someone makes a small little mistake and it gets the wrong answer. Okay, so you just want to really be careful with that. All right. So now let's get into formulas, okay? Because after we figured out like how to start solving things, they start to throw in these equal signs, and that's when you're actually evaluating for a variable. You want to know how much something is. So like I said earlier, an equation is formed when there is an equal sign inside of your expressions. So it's going to be placed between two separate expressions. So again, remember, an expression could be a combination of a letter and a number, or it could just be a letter, or it could just be a number. But when you start to have expressions with an equal sign in the middle, they're switching it to an equation. We use formulas a lot to represent relationships between things like shapes or quantities. And so when we're using a formula, we're basically solving an equation. So for example, we've got this formula: t equals 4x squared plus 330x plus 3,310. This models the average cost of tuition and fees. So that's represented by the T, capital T, for public U.S. colleges for the school year ending X years after 2000. Project the average cost of tuition and fees for the school year ending in 2022. So we're going to use that formula, but what we need to figure out is what we're putting in for X. So they had this model created like the year 2000. So they kind of based it off of the year 2000 and going forward. So that's where we started. They want us to project how much it's going to be in 2022. So how many years passed there?
22 years.
22 years. So that's going to be your X. It's been 22 years since this model was created. They want us to be able to project how much tuition is going to be. All right, so that's going to go in for X. So 4 times 22 squared plus 330 times 22 plus 3,310. Go ahead and do that. Does anyone need a calculator? Okay, go ahead and solve that. What do we get for a cost? Good. That's what I got, 12,506. Okay. Now down below it's saying, what does Google say the average cost is? And let's see how close our answer is. So I'm just going to pull up Google here. And we'll ask average cost of public college in 2022. We'll see what we get. So depending on if you're in-state or out-of-state, that's going to change. But if we just look at the in-state, it's pretty close. I mean, we're off a little bit, but it's pretty close to what we got because they're saying it's like 10,940 for in-state, and we got 12,000. But again, it could just be the way that they represented this. It's not going to be exact. It's not going to be able to predict exactly how much someone has to owe, but it's still fairly close. It's off by about $2,000, $2,500.